Hi, welcome to Concept Based. I'm John Hepworth. This is the Year 11 advanced topic. We're into Introduction to Differentiation. Welcome to the world of calculus, something that you haven't done in stage 5. So this is absolutely brand new, and the Introduction to Differentiation starts off by some realizations of what we're looking for that requires us to actually have calculus. The thing we use to look for it in the beginning usually is some sort of physical application. So let's have a look at a question. Given the following distance time graph, calculate the instantaneous speed at time equals 4. Now, we've done these types of questions in stage 5, but we've done them as approximations, and that's all we can really do at the moment until we learn some calculus. We know that speed equals distance over time, and we want to know what our speed is at this instance in time when time equals 4. Now, what we've done in the past is just said, well, let's approximate from, say, when time equals 3 to time equals 5. I might just zoom in to do this approximation. And I draw a line between the two. And then from that, I can draw my triangle. And I can say, how much is it rising? Well, we're going from about 3.1 down to 2.4. This is about 0.7, but we're dropping. We're going from up there to up here to down here, so it's a negative. And the time that passed was 2 seconds. So we can replace our distance with negative 0.7, and we can replace our t with 2. And that means we're going to get an instantaneous, not an instantaneous, of negative 0.35 meters per second. Now, what I want you to learn from today's you can go to my YouTube channel and have a look at this video where I go into a Desmos explanation of what's going on here. The link is in the description. But if you look, the actual line we drew is really close to being the tangent at the point. So the idea here is the tangent is the gradient that we're looking up for as this approximation of these points gets closer and closer to this point. So we're looking for the gradient of the tangent of a line at anywhere on the curve. Now that's about as an introduction to calculus sentence as I could give to you. And that's what we're going to be looking for in the future is we're going to be trying to find gradients of curves at particular points.